The number e is one of the most famous numbers of all time. At around 2.718, it even gets its own button on the calculator alongside pi. But what is e? If you have been exposed to calculus, you might know it as the base of the exponential function, whose derivative is equal to itself. And others know it from pre-calculus, which says if you deposit $1 into the bank, offering 100% interest over 1 year, in 1 year you would have $2. But what if you gained 50% interest every half of a year? Then after 6 months, you would have your $1 times 1 plus 50%. Then after another 6 months, you would multiply your money by this again, resulting in slightly more than $2. In general, if you gain 100 divided by n interest n times a year, your total money after 1 year would be equal to 1 plus 1 divided by n to the power of n. Now what is the maximum amount of money you can get in 1 year by doing this? Well, since it seems that the more times we compound our interest a year, we get more money, we can just take the limit as n approaches infinity, and we get e dollars. But if you're anything like me, you probably wondered, why are these the same? When you try to calculate the compound interest definition of e, it sure looks like it approaches e. But looking like it approaches e and actually approaching e are two completely different things. All it takes is the 20 billionth term to not be the same as the 20 billionth term in the original e for them to just completely not be the same number. So today I will present a proof that the compound interest definition is the same as the calculus definition. But first we must ask a question that seems to not have anything to do with our original question. What is the derivative of the natural log of x, where the natural log of x is just the inverse function of e to the x, written ln of x. So if ln of x is equal to y, this is exactly the same thing as saying e to the y is equal to x. So now let's take the derivative of both sides. We get the derivative of e to the y is equal to e to the y times dy by dx from the chain rule, and the derivative of x is equal to 1. And then we divide by e to the y to get 1 divided by e to the y is equal to our derivative. But we want our derivative in terms of x, so we substitute our y for ln of x to get 1 divided by e to the power of ln of x. And since the e and ln cancel out, we are just left with 1 divided by x. Now what we just said is logically equivalent to the antiderivative or integral of 1 divided by x dx is equal to the natural log of x. Or the definite integral from 1 to n of 1 divided by x dx is equal to natural log of n minus natural log of 1, or just natural log of n, since natural log of 1 is equal to 0. And remember, the integral is just area under a curve. So if you look at the area under the curve, y is equal to 1 divided by x, from 1 to n, the area should be equal to the natural log of n. So let's take the area from 1 to 1 plus 1 divided by n. This area should be equal to the ln of 1 plus 1 divided by n. This area is obviously less than or equal to this outside area, which is equal to 1 times 1 divided by n. And it is greater than or equal to this inside area, or 1 divided by n times 1 divided by 1 plus 1 divided by n. Now you might already be able to see where this is going. Now we can multiply all sides of this inequality by n to get 1 divided by 1 plus 1 divided by n is lesser than or equal to n times ln of 1 plus 1 divided by n, which is less than or equal to 1. And we know from our logarithm properties that this n times ln of 1 plus 1 divided by n is equal to ln of 1 plus 1 divided by n to the power of n. Now this is starting to look very similar to our compound interest definition. All that is missing is the limit as n approaches infinity. So let's just do that. And we get 1 divided by 1 plus 0, since 1 divided by n as n goes to infinity goes to 0, which is lesser than or equal to the natural log of the limit as n goes to infinity of 1 plus 1 divided by n to the power of n, or our compound interest definition of e, which is less than or equal to 1. And so now we have something in between 1 and 1. So this must be equal to 1. And so what we get is the natural log of our limit as n approaches infinity of 1 plus 1 divided by n to the power of n is equal to 1. And so the limit as n approaches infinity of 1 plus 1 divided by n to the power of n, or our compound interest definition, is equal to e. And so both of our definitions are the same. I hope you enjoyed learning that the e you knew from pre-calculus is the same e you learned from calculus. Thanks for watching.